Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our two panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We'll also have two polling questions during today's webinar, so please, hopefully we can get everybody involved in that and answer the two polling questions. And then finally, at the end of today's webinar, we are doing a drawing for three $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our three lucky winners. All right, with that, we'll kick off today's webinar, which is Observability in Java, getting started with OpenTelemetry. Easy for me to say. Our speakers today are Katie Farmer, who is Developer Relations Manager at LightStep, and Ted Young, who is Director of Open Source Development at LightStep. Welcome to you both. Thanks for joining me today.
Thank you for having us.
Awesome. Well, I'm going to turn it right over to you, Katie, and put myself on mute, let you get to it.
Thank you so much. We are happy to be here, and thank you all for joining us. I hope you're well and taking care of yourselves. We're going to be talking a little bit about OpenTelemetry and observability and just a splash of Java for you all today too. So let's hop right in. I'm Katie. I am Developer Relations Manager. You can also see sometimes I'm called a Developer Advocate. Basically, my job is to be an expert, in this case, LightStep and OpenTelemetry, and to make sure that you know how to use the tools. So if you have questions, I am out there on the internet available to help. I've been at LightStep a relatively short amount of time, since the beginning of this year. So I'm still learning, and there's no better time to learn than to learn with all of you at the same time. So with that being said, I've brought along a friend to help.
Hello, my name's Ted. I'm Director of Open Source Development at LightStep. I'm one of the founders of the OpenTelemetry project. I've been at LightStep for a while, I think over 3 years, which is like 18 years in startup years. But I spend most of my time working on OpenTelemetry and open source projects on behalf of LightStep.
Cool. Our first poll question.
Yes. We do have the first of two poll questions coming on your screen right now. It is, do you currently use distributed tracing? You can go ahead and answer yes, no, or no, but considering it. And we'll give you guys about 30 seconds or so to make your decision, and then we'll go ahead and close the poll and show you the response. Looks like we are coming on the 30-second mark here. So 3, 2, 1. Okay, I'm going to go ahead and close it out now. Let's take a look at the results real quick. Looks like the majority of folks are not using distributed tracing. So I'm sure that gives you guys lots to talk about.
I mean, hooray. So let me pull my slides back up here. Cool. Well, yeah, a great place to start then. If you're not using any of these tools, then the best place to start is just with, well, what is observability? If you have been at any conferences and you've been in like the vendor area in the last like year or two, you've probably seen observability just like floating around on various signs. And like most good buzzwords, it sort of means nothing and a lot of things. So the idea here is that software has transformed, and it continues to transform the world around us. It's so integrated into everything we do, especially now. And it's only going to become more important, which is why we want to be able to rely on these really robust systems. But if you're a developer, then you probably know they're incredibly fragile and complex right now. There's all these different languages and frameworks and service meshes, on-prem, off-prem, some things that maybe have to stay connected to legacy software or even a mainframe, which I myself have even used once or twice at a previous location. It was terrifying and wonderful. But there's also just like all these layers of architecture with these hidden dependencies, and any one of them could be responsible for some kind of incident, right? So that's why observability and monitoring are so massively important in making a business successful. It's kind of the only way to assure that some quality control can exist and that people and developers can get back to what you actually want to do for a living, not just fixing things, but actually developing and building really cool things. So being able to successfully identify regressions and errors across all of the complexity presented in these systems is extraordinary, right? I mean, isolating issues upstream, downstream from a single service is really challenging across a distributed environment. Every problem that starts out easy gets more and more complicated in a distributed environment. That's why, I mean, well, this is sort of like what LightStep was built to do, is to sort of address this problem. So let's talk about a couple definitions of observability, because I find it takes a couple to really have it sink in. So first, you need visibility across all of those layers we've been talking about. You want to adopt tools that provide visibility end to end across all requests. And it's got to be presented in a way that, well, actually lets you get to important information, like, I don't know, maybe a bad deployment or a specific error, or which of your customers are affected. Like, how do you get to relevant information? So this is my favorite definition of observability right now, which is the ability to navigate from effect to cause. So there's a reason I'm not saying like cause and effect, because if you're like me and you spend time developing, you don't really get to the cause until much later. You start with the effects, and it might be a spike in errors. And then after you dig, you might discover it was a misconfiguration. You'll see increased latency, and then maybe discover new customer behavior. The idea here is that we see symptoms long before we see the actual cause. So observability is basically our ability to navigate from that effect all the way down to its cause. So how did we get here, Ted?
Yeah, so what happened? We've had observability tools for a long time. We've had logging and metrics. Certainly since the 90s, I feel like the tools I've been using haven't changed that much. So what happened recently to cause these existing tools to be insufficient? So next slide. So back in the day, right, I'm sure people have heard this story before. We tended to deploy single monoliths. This wasn't just you had a single instance, but maybe you were using a single language, a single framework. Things were fairly uniform. The amount of code maybe involved was fairly small. And then as time has gone on, as services have grown, they've scaled up. And we've scaled up in a lot of dimensions. It's not just that you're taking your existing monolith and now horizontally scaling it in order to handle more load, though that does increase complexity. We're scaling technology across many axes. So if you look at a web transaction today versus a web transaction from 10 years ago, every transaction is interacting with more service instances, so more instances of the same service. Every transaction is interacting with more different types of services. The number of languages, frameworks, proxies, runtimes are growing longer and longer. We've got service mesh now. We've got serverless. People are migrating systems. Basically, the total number of lines of code is growing over time. And if you look at real world systems, so next slide, yeah, if you look here, these are examples of existing LightStep customers that have been anonymized, and these are just their service diagrams. You can see that they're getting really complicated. And even a monolith today isn't really a single service, right? People say they have a monolith, and lo and behold, they've got something running with a proxy, with a web cache, a CDN might be involved, multiple databases might be involved. So even something that's quote unquote a monolith is actually a cluster of services. And this change reached a tipping point where your average web request is now hitting more than 3 services. And when you're at that point, it becomes hard to just look at one service and understand what is going on in the entire transaction. So that kind of situation is what we're starting to call deep systems.
Yeah, I think that's you can sort of see through those, diagrams just how complex some of these can be. And there are a lot of ways for complexity to increase, like you were saying, Ted. I mean, there's maybe just adding more hardware to fix a problem, or maybe you can solve it with more, like cloud services or what have you. But what we're talking about are deep systems, which look exactly like that last slide. So basically what that means is it's not just a distributed system, right? It's also deep. And we call them deep systems because their dependencies are the dependencies that are sort of natural in these multi-layered architectures, they lend themselves to like extreme lack of visibility. Everything is a little confusing. And it's really difficult to figure out when, what, and why things are broken or slow. You could work at any one of the layers you see on this slide, right? So maybe you work only at the very top of this pyramid. Maybe you just work on client APIs, but changes you make can roll out all the way to affect a managed service. That's something you are now responsible for that you can't really control. So when we talk about deep systems, what we really mean are systems that are complex in new ways, where these layers of dependencies make it difficult to find out what's going on. Another poll.
Hooray, we have another poll. We're going and launching it now. What is your biggest pain point for monitoring performance? You can select from too many tools and tool training, service dependency visibility, performance incidents, or deployments. Go ahead and make your selection, and we'll give you guys about 15 seconds longer to make your selection, and then we'll close the poll out, take a look at the results. While you guys are doing that, I do want to remind the audience that you do have plenty of time to submit your questions, but you can do that at any time. Just use your GoToWebinar control panel and submit your questions. And hopefully we'll get to as many as we can during the question and answer period. Okay, looks like we are just about there. So I'm going to go ahead and close out the poll now and take a look at the results. Looks like the majority are experiencing the biggest pain point in service dependency and visibility, but too many tools and tool training is a very close second. So there you go.
That's fascinating.
Right.
And I think pretty relevant to what we're talking about, Ted, right? Like this idea that I like that it's sort of a tie between the two. Also, like, there's too many tools and the training is really hard, but also it's hard to see. So this is great news. Ted, do you want to take over and tell them one possible solution to those problems?
Yes, so I've been dealing with this issue of systems that are too large to observe with traditional observability tools for a long time. So I joined a project that was originally called OpenTracing that sought to be a new standard. Another project called Open Census started around a similar time with similar goals, and everyone in those communities started collaborating to the point that we decided to merge the projects so that we could really truly have a standard rather than just two competing projects. So when it comes to too many tools, we went from 2 tools to 1 tool. So that's helpful. And also just FYI, OpenTelemetry is backwards compatible with OpenTracing and Open Census. So if you are using one of those projects today, you can migrate to OpenTelemetry without any kind of breaking changes happening to you. So that's also important to us. But the main point of OpenTelemetry is to be a one-stop shop for observability. So it's just a single set of everything you would need to actually observe your system from the telemetry standpoint. So just to clarify the boundary of the project, this is everything you would need to install in your system for observability to work. Once you get to the point of analyzing the data coming out of the system, that analysis system, OpenTelemetry doesn't ship with an analysis system. The idea is we want to standardize what the data looks like, but actually analyzing that data, that's an area where there's just a lot of innovation going on. And that's where you would plug in a tool like LightStep. There's some open source equivalents as well, but obviously LightStep's the tool that we prefer. So OpenTelemetry works with basically every major observability system out there. All of the large vendors in the space have adopted it and are actively building the project. So it's really got broad support in the observability community. But just to explain why OpenTelemetry is different from, say, prior tools, it really comes down to context propagation. So if you look at this diagram of a deep system, and then you imagine a single transaction, say a web request from a user coming in, you can see how this transaction would propagate through this system, eventually touching some leaf nodes at the bottom, say several databases. So if you want to know what's going on in this transaction, the first issue is finding the relevant data. I'm sure people have had this experience trying to debug large systems where the first really difficult task is just filtering and scoping the amount of data you're looking at to just the relevant data. And as systems grow in size and complexity, as they become more distributed, it becomes harder and harder to do this scoping. There's just too much noise, looking for logs in all of your logs, just like looking for a needle in a stack of needles. So in order to help with that initial stage of the investigation, you have to contextualize the data that's being sent from your system. You can't just do the contextualization in your analysis system on the back end. You actually have to do it in your system as it's running. And so we refer to this as context propagation. So this is making sure every single event or metric or log coming out of your system is indexed correctly, so that later you can group that information by transaction. You can group it by resource, say, which transactions are interacting with service A versus service B. You want to group things by product attributes, which transactions were being made by account A versus transactions being made by account B. So there's all these different ways you want to scope your data as part of your investigation. And if you've tried to do this in a complicated system and actually contextualize all your data, you'll discover that it's a lot of work. A lot of the indices, a lot of the keys and values that you would like to staple onto every log so that you can find them later are produced in services other than the one you might currently be looking at. So the classic example is a transaction ID. If you want to know every single event that occurred in this transaction, then every event needs to have the same transaction ID. So that transaction ID needs to get propagated through your system as the transaction goes through your system. And setting that up is a lot of work. And so the primary focus for OpenTelemetry is doing that context propagation for you, getting that all installed and ready to use without you, the end user, having to do a lot of that heavy lifting yourself. So that's a critical feature. Yeah, and if you look at this a design diagram of OpenTelemetry's architecture, you'll find when you start using the project, there's a sort of lower level of context propagation features that are kind of general purpose. They'll propagate any kind of context. And then OpenTelemetry comes with several observability tools that leverage this context propagation. So we have distributed tracing, which is about basically, I call distributed tracing, smart logs. Other people take issue with that description. But tracing is basically a way of measuring, one, recording all of the events that happened in a transaction, but then also recording latency. So understanding how long how much time is being spent in particular sections of the code. So it's not just a measure, it's not just your events, it's also measuring how long those events are taking to execute. We also have traditional metrics, but these traditional metrics are also contextualized in the same way. So we have a correlations feature that allows people to just any kind of indices you'd like to have on your traces or your metrics be propagated and be available to all of these systems. So you're still doing metrics in a way that looks like perhaps how you're doing it in the past, but those metrics can now be related to traces. They can be scoped and indexed in a way that was difficult to do in the past. And this is also an extensible system. Once you have something like context propagation in place, you might discover you have other uses for it in your system. A/B testing in a distributed system is one example of where things get complicated. Flowing authentication and authorization information through a system. These are, you might find once you have context propagation in place and reliable, you'll find a lot of different ways to make use of it. So that's the high-level overview of OpenTelemetry. Let's dive into Java specifically. So this won't be a deep dive into the Java APIs and all of the details. We don't have time for that on this particular webinar, but this will just be an overview about how to get set up with the project. So it's actually pretty easy. Go to the next slide. OpenTelemetry works with Java 7 on up. And when you want to get started with Java and any other language, there's just a couple easy steps. You have to install the core OpenTelemetry libraries. You also have to install what we refer to as instrumentation adapters. So basically, most of the code you're running in your service is probably not application code written by you. Most applications these days are built out of off-the-shelf components, usually open source components. So think about your web framework, think about your HTTP libraries, think about your database clients. Those are all really critical pieces of code, and they're especially critical for context propagation. So if you're trying to propagate context, you need to have OpenTelemetry installed in everything that's managing your code. So your HTTP library that's making requests to the next service needs OpenTelemetry installed into it, so it can inject that context propagation. Your web framework, which is handling which application code is being written, is being executed, that code needs to have all of this context and tracing set up within it so that you as the application developer don't have to worry about that so much. So OpenTelemetry comes with instrumentation adapters that will need to get installed in order for it to work. Finally, you need to configure all of this, and then in some cases you do need to actually decorate your application code, but we'll get into those details. So how do you do this in Java? Well, luckily Java has the Java agent pattern, which automates all of this, and that's really great. We refer to this as auto installation because in languages other than Java, it's not generally referred to as an agent. But since we're on a Java call, we can just say agent. So the OpenTelemetry Java agent can be found at the OpenTelemetry Auto Instrumentation Java project. The link to it's in the slide. And I've just pasted the default kind of configuration options. So the following line of just like attaching your Java agent jar to your application, that's good enough to get going with OpenTelemetry. So that's a critical feature. If you want to get started with OpenTelemetry, you should be able to just install the agent, and then you'll start propagating traces and be able to see data in your backend. You don't actually have to start with instrumenting your application. So next slide. And so these are the library adapters we currently have for Java. You can see we've got a pretty deep bench of support already. And this comes from the fact that even though the OpenTelemetry project just went into beta yesterday, so it's OpenTelemetry itself feels fairly new, it's built out of prior art from these existing projects. So we've already been working on this project for several years, so it was very easy to port over all of our existing support to OpenTelemetry. If you're interested in general in finding what's supported by OpenTelemetry, the website has a registry. We're in the process of adding a listing for every single library and plugin in the OpenTelemetry ecosystem. So check that out on the website. That's a good place to go to find out what kind of support is available. Okay, so configuration. So what configuration options do you have to think about, even when you're using some kind of auto installer like a Java agent? And there's really two primary configuration options when you're setting up a telemetry system that you have to think about. One is your propagation option. So if you're going to be propagating this context, there are actually a couple of different standards available out there for doing this. They all work well. The critical thing here is you have to pick the same one in every service. So if one service is configured to use the new W3C headers that have in the process of being standardized, but it's trying to talk to another service that's only expecting B3 headers, then context propagation will break. So this is the most common configuration error that I see, is having broken context propagation because different services are configured with a different propagation option. So luckily we're trying to standardize this so there are less options. There's a W3C working group that I've been a part of for several years. So we are adding official tracing and context propagation headers to the W3C. They'll probably get baked into the browsers, and you'll see them getting baked into other off-the-shelf pieces of software. The other piece of configuration information that's critical is your exporters. So this is where and how are you sending data out of your system to your backend. And of course, there are a couple of options here. If you're talking to LightStep, we have LightStep exporters in every language, so you can send data directly to LightStep. There's also the OpenTelemetry collector, which is sort of a proxy or middleman piece of equipment. And that's useful if you're trying to have some, like a sort of control plane for where you're sending this data. OpenTelemetry has a native data format called OTLP. And so you would use that if you're talking to the OpenTelemetry collector. So I would say when you're thinking about exporter options, your first question is, do I want to run the collector? If so, you want OTLP. Otherwise, if you're talking to LightStep, you just want to use our LightStep exporters. There is also a warning I'll put here, which is OpenTelemetry does offer some sampling configuration. Some systems rely on sampling, some backends rely on sampling in order to function, but just to clarify, LightStep is not one of those systems. Katie, I don't know if you have any color on why LightStep doesn't require sampling.
Yeah, so LightStep has its own system that we call dynamic sampling, and it relies on having 100% of data. So you don't want to sample the data with OpenTelemetry and then send it to LightStep, because then LightStep won't be able to do what it does really well. The idea is that LightStep uses 100% of data, analyzes it, and then is better able to make accurate analysis of the data. So if you pre-sample it with OpenTelemetry, you're sort of limiting LightStep's ability to analyze it correctly, because LightStep uses what we call 100% data process. So just make sure that if you're sending it to LightStep, you send 100% of the data so we can be super accurate.
Yeah. But that's really all you need to get started. So we can talk a little bit about application code and how you use the OpenTelemetry APIs to decorate your application code with additional detail. But I do want to clarify, if you just want to get started and you just want to like see your data in a backend, you don't actually have to write a lot of application code. You don't need to be figuring out how to make this context propagation work yourself, provided that you are using libraries and frameworks that OpenTelemetry has support for. So if you just stand the system up with the Java agent, make sure everything's configured to use the W3C standard propagation headers, and point it all at LightStep, you should see your traces working and you should be able to see the data. But of course, as you get used to this system, you're going to want more detail. And as you want more detail in your application code, the code that isn't a standard library or framework, you're going to want to decorate that code the same way we've always done it, by things that look sort of like log statements and metrics. So OpenTelemetry has several APIs for doing this. I think they're fairly easy to learn. You can go to LightStep. We've got some docs on how to get started with OpenTelemetry that'll walk you through creating your first span. And I would encourage you to just look at the API docs on the project itself if you want to learn these details. I'm happy to do another talk another time that really dives into the details of these APIs, but we don't have time here.
I know there's never enough time for all of the like amazing work that a lot of people have done on OpenTelemetry.
Yeah, but sometimes these APIs get put in the front, and people get the mistaken impression that in order to use something like OpenTelemetry, they have to first write a lot of tracing code.
Yeah.
But I want to clarify that that's not the case.
Yeah, I mean, I always say, like, if I was able to do it in like 10 minutes, then like anyone listening today can definitely do it.
Yeah. All right, but let's assume you've got that all set up, and now you're exporting your data to LightStep. Like, what can you actually do with this data?
Yeah, I mean, it's interesting, right? Because obviously we want to be able to instrument our code. And we learned from that earlier poll, right? A lot of people have some trouble with service dependency visibility. So how do we then go from like, we're collecting this information to like, it is actually useful and relevant? And so we're taking a look here at one of LightStep's pretty cool features, I think, which is to easily be able to pinpoint performance issues. Go to the next one. So if observability is our ability to navigate from effect back to cause, then what do we need to be able to do? Well, first we need to be able to easily see and understand your deep system, your highly distributed environment. Maybe a lot of you are keeping what I'm going to call like a mental model of these systems, right? Like if you have worked in your current environment for a while and you have some, you get that context over time, right? You start to understand and build this mental model, but that's not available for new team members or people in other organizations or even just in other orgs in your company. So we want to be able to immediately pinpoint performance regression, figure out like what happened. You want to be able to enable developers to ship with confidence. And this is like kind of a marketing point, but also when I like really thought about it, I liked it more and more, because as someone who was like new not that long ago, like your first, deployment, you don't want to be a scary experience. And if there's something wrong, You want to know as quickly as possible. So the next 2 points are that we want to enable easy sharing of information and to keep context, which I think is really related to what Ted was talking about earlier. The same way that we want context propagation through our like traces and instrumentation, we want to be able to keep context with the information available in LightStep too. Because I don't know if you've ever had someone like, let's say like interrupt you, ask you a question about a problem or an error that they have. That context switch is like, it's hard for all of us, right? So the idea here is that the context is built into the tool. That way, when you go look at a service, you have all the information necessary so that you don't have to go, like Ted said, digging through the, stack of needles. You don't want to miss insight, right? You want to be able to like learn and get better all the time. So we sort of call this observability with context. And LightStep has a lot of pretty cool features, I think, but one of the ones that I'm sort of focused on right now is the automatic deployment regression and regression detection. Okay, so this is one, it's fun to say, you should try it. But this idea that like you immediately get insight into any regression. So there's a screenshot here that's sort of showcasing this functionality where we're automatically via tags identifying the deployment by version number and then charting the latency and the error rates. So then you can easily investigate regressions, compare versions to see the performance differences in operations, tags, traces, what have you. So then you can investigate all the way down to the log and error message. And then you can like view these detailed inter-operational diagrams to sort of like, again, keep that context and understand like what is being affected. We also sort of offer what I'm going to call aggregate trace analysis, which is related to the sampling we were talking about earlier. So other tracing solutions have two problems, which first, they generally follow aggressive sampling rules that limit the data collected. And that can stunt the effectiveness of the analysis. There's no way to measure what you don't collect, which is why we were giving you the warning that if you change the sampling configuration in OpenTelemetry, then LightStep might not be able to do what it's going to do. So LightStep analyzes 100% of the traces, and then it constructs like meaningful models of your data so that you can more easily see like patterns and like the shape of your data over time. And I like to think that one of the things that we do better is that other tracing solutions often capture traces individually and then they present them in the UI as like a list, but like that's not helpful to me because that's just another stack to sift through. So I want to again point you to these nice little diagrams of what you can do, but almost more importantly, obviously LightStep is super cool. I like it. You should try it. But we don't want vendor lock-in on the OpenTelemetry side or the LightStep side. So as far as OpenTelemetry goes, yeah, you can absolutely export your data to LightStep, but you don't have to. If you already have an instrumented application, you can send that data to LightStep. This is a very like modular setup to make it easy for what you have going on. The point where Ted said you could sort of get going, like up through sort of that SDK configuration portion, you should be able to right then start sending data to LightStep. But you could also, just like do a console log and print out some traces and be happy. Like the way to sort of understand your data is simply to get started. And on that note, what I want to encourage you to do is to try the LightStep sandbox. One of the things that kept me from maybe understanding and doing a really good job like researching these observability platforms is that you can't just use them, right? They usually require this, you know, highly distributed deep system for you to understand. But at LightStep, we understand that you need more than that. So we made this sandbox. I am in love with it. Basically, you work through a scenario. So you sign in and you see exactly what it's like to go find a root cause analysis. So like go through that process and see what it's like in LightStep. I am just like big fan, can't say enough about it, just because it helped me understand system visibility better, to be able to play with data that's not yours and doesn't make you sad because nothing's actually broken. So I think you should get started with the LightStep sandbox, but this is where we usually stop and do the questions. So let's do questions.
Awesome. Yeah, if you have a question for either Katie or Ted, sorry about that.
That's all right.
Go ahead and use your GoToWebinar control panel and submit your questions. Let's go ahead and dive right on into what we have. We've got a ton of them in so far. Let's see, do you have some benchmarks or results between tracing versus distributed tracing and with which tools you achieved?
Between tracing versus distributed tracing, I'm not quite sure I follow that. I think maybe the question refers to tracing as in something like dtrace, like a system like our kernel tracing. Distributed tracing does have more overhead than something like kernel tracing, but distributed tracing is not used for like fine-grained microanalysis like you would be using kernel tracing for. So the kind of timing and latency information you want to get out of distributed tracing is very coarsely grained. So you want to know on the level of, say, components. So within this service, was all the time being spent in the database client or in the controller or in rendering the view? It's not on the level of like how many syscalls were made inside of this function.
Okay. All right, great. Let's see, if you want to get clarification on that, Florian, go ahead and just submit a follow-up question. Okay, next question. How much will OpenTelemetry affect performance?
That is a good question. The project just went into beta, so it's in its early days. So we have not yet done any performance analysis or overhead, though given that it's based on existing work, unless there's a bug, I don't expect the impact to be above, say, 4% of total systems usage. There is an interesting feature here, I will say, which is there's kind of a bimodal distribution when it comes to observability users. There's people who want a framework that's very flexible, so they can install a lot of plugins, key their data off to a lot of different systems, do a lot of different kinds of things with the data. And there's other people who want a system that has no features, it's just purely tuned for performance. And we haven't built this yet in OpenTelemetry, but because of the way the system is architected, it's very plug and play. So you can take all of your OpenTelemetry code and then plug in a different SDK to actually process that data. So if you come up with a more performant implementation, you can swap that in without having to re-instrument your code or change what kind of data protocol you're using. And one concrete example of that is a C++ implementation. So for languages like Python, for example, rather than having a Python SDK using foreign function calls to bind to the C++ OpenTelemetry project. That work is kind of underway, so that's not something available yet. But this is something we did do at LightStep as an example in Python. So you can look at the LightStep Python streaming tracer, takes the Open Tracing API, and then binds it to our Open Tracing C++ implementation. And the performance there is really incredible. So I do believe it will be possible to get really good performance out of OpenTelemetry in the long run. In this early beta stage, though, I would say for like highly performant systems, you would want to measure it and be a little careful.
All right, great. Next question. Can correlation through IDs join incidents from effect into a common cause?
They can. The primary thing you're looking at is transactional IDs. But yes, usually you're trying to find what is the commonality. So when you're doing a root cause, you want to understand, is it something to do with, say, certain kinds of input values create errors? So when a web user is sending a certain kind of payload, that's creating an error on a backend service. And you can certainly do that kind of analysis with OpenTelemetry and distributed tracing. But as I mentioned before, you can also add correlations for product metrics and other concepts that you care about. So if it's something you'd like to scope your data by, and that is available to your application at some point during the trace, then you'll be able to do the correlation.
All right, great. Let's see, next question. Does LightStep support the Open Collector?
The OpenTelemetry collector. Yes, there is a LightStep. LightStep is baked into the OpenTelemetry collector, so you can turn the collector into LightStep mode where it uses LightStep exporter, and then it can talk to our system. I should clarify that you don't need to run the collector. LightStep has a service called a satellite, which provides all of the trace analysis and trace aggregation that we want to do on-prem. So all of the information that you would want to be processing before it egresses your local network and takes a hit for that egress cost, you would use LightStep satellites for that. But LightStep OpenTelemetry collectors can talk to LightStep satellites. So we do see customers set up two pools. They set up a collector pool, and they use that for kind of traffic routing, and then they set up the satellite pool for the data analysis.
All right, great. Okay, next question. Can I export to Power BI?
I do not know what Power BI is.
Me neither.
All right, Reg, it's up to you. Go ahead and send us a follow-up if you can. Please explain what Power BI is.
I mean, this is a good time to note that this is open source. So if you want to contribute and write exporters, well then, do we have an opportunity for you?
Yeah, something I hope to see over time is because OpenTelemetry has a standard data format, you don't have to, if you want to have a new kind of analysis system or backend, you don't have to go across every language and write an exporter. You can just make that backend either accept OpenTelemetry data natively, or this would be an example of what the collector is useful for. You could use the collector as a conversion point for converting that data from OpenTelemetry format to whatever format the analysis system you're using wants to see.
All right, great. So just real quick, once again, if you have a question for Katie or for Ted, please go ahead and use your GoToWebinar control panel. Still plenty of time for questions, folks. Speaking of, next question, how easy is it to turn up or turn down the amount of tracing?
Turn up or turn down the amount of tracing. So I think this gets back to the dynamic sampling that Katie was talking about. LightStep doesn't use upfront sampling. Instead, data is sent to the satellites, so we collect 100% of data there. And then the data that's actually egressed from your system is only data that's identified as being relevant. So that would be outliers that the system is noticing, errors, and also any data you've already configured LightStep to care about. So if you're setting up analysis in LightStep, that causes the satellites to change their behavior and start producing the data required for that new analysis feature that you enabled. So the idea there is that LightStep manages the egress and tries to minimize egress costs automatically.
Excellent. Okay, I got a follow-up from Reg. He says Microsoft Power BI is used for data visualization and is used in my company to view data.
Oh,
Yeah, cool.
it just
So-
hasn't come across my radar yet.
Yeah, I think the thing here, just not knowing anything too much about this data visualization tool, I'll admit I am Googling it right now and looking at it. It does look very
Me
good.
too.
It has a lot
Wow.
of really cool graphs. The key here is I don't know if this is like, presumably this is a managed service that has some kind of a database where you have to get the data into the database in order to visualize it in this tool. So
Yeah.
the real question there is, what are the performance and cost characteristics of getting the data into this tool in order to analyze it? So if you wanted to look at this in Power BI, I would say step one is look at how Power BI wants to ingest data and write a collector plugin to translate from OTLP to Power BI. Then there's going to just be the question of like, how does that thing scale up? You know, does it scale up effectively so you can monitor a production system? How much does it cost at that scale? Those are, I think, the kind of relevant questions. And since we don't use Power BI, I'm afraid I can't answer them.
Okay. All right. Let's see. Next question here. Any plans to add tracing using eBPF?
eBPF. I'm going to Google that one too.
Another Google search.
I think.
Oh, okay. So this is, yes, BPF. Sorry, this is more kernel tracing. Yeah.
Yeah, I was going to say that's kernel tracing, right?
Right. So
Okay.
it's actually really tricky to staple distributed tracing and kernel tracing together. That is really interesting. In my fantasy land, I would love to be able to dynamically enable kernel tracing based on things that I'm noticing with my distributed tracing. So I'm investigating, I'm root causing a system. I'm like, whoa, what's going on right here? Turn on kernel tracing for just this one thing, and then send me a dump. In practice, that's kind of dangerous to do in a live system. So no one's built a tool like that, but that is exciting. The other issue is actually just the timing information. Kernel tracing is on such a microgranular time frame that even a small offset in the timing can disassociate the kernel tracing events from the distributed tracing events. And because distributed tracing events are somewhat coarsely grained, just getting those timestamps stapled together and aligned is actually a tricky issue. I have seen some like graduate student research on this subject, but it's not percolated out into the industry yet.
All right, great. Doing a quick time check. We have about 7 minutes to the top of the hour. I think we have time for one more question. And this one is kind of a long one. So let's see. With Java, VM operates on top of VMs or similar hypervisors. Time is no longer accurate. The response time on Java VM is higher depending on how the garbage collection configuration on the Java VM is. So real-time Java VM has a CPU core to handle garbage collection. So what is the recommendation on Java VM garbage collection with LightStep? Mouthful.
Yeah.
Well, I don't think we can make suggestions about how you tune it, but there's certainly the question of like wanting to know, is this latency caused by resource contention, or is this latency caused by algorithmic complexity? So in other words, something's taking a long time. Is that intrinsic to the operation that's happening because you're just stuck in a very long for loop? So it's just core complexity versus incidental complexity, or is the issue that this code might run fast, but if you are running lots of other code at the same time and you're contending for resources, then you're seeing latency as a result of that contention. And garbage collection pauses are a great example of resource contention. Another good example would be queuing, waiting for a lock. So my code would be fast, except other code is contending for the same resource. So we're all queued up behind this lock. And you can see some of that information in OpenTelemetry. This is where having the sort of metrics that are monitoring things like CPU and memory and GC events, being able to correlate those with the transactional traces that are flowing through those systems. That's definitely a core competency of this new project. I think it might take a little bit of time for that to move from features OpenTelemetry has to features that analysis systems are providing. So I'm not sure if people are providing things like GC analysis yet with OpenTelemetry, but in the future, you'll definitely be able to do that.
And I do want to note too, someone really kindly put the link to this in the questions, but one of our engineers, Alex Boaton, is giving a talk on eBPF plus OpenTelemetry at Cloud Native Rejects, which is a virtual conference. And I think it's happening live tomorrow. But yeah, you could always tune in there, and I'm sure there'll be recordings of it in the future for more of a deeper dive.
Yeah.
All right, great. Thanks for pointing that out, Katie. Okay, we're about 4 minutes to the top of the hour, so unfortunately we do have to close out the question and answer period. I do want to thank everybody who did submit questions, and if we didn't get to your question, please, I'm sorry, first of all, sorry we didn't get to your question, but please know that the folks at LightStep will be getting a copy of all of the questions, so please be assured that somebody will be following up with you offline to get your question answered. And also, I know I said at the top of the hour that we would be doing a drawing for 3 $50 Amazon gift cards. So without further ado, let's go ahead and do that.
Woohoo!
Woohoo! Our first winner today is Herb P. Congratulations, Herb. Our second winner today is Lauren K. Congratulations, Lauren. And our final winner today is Miguel Z. Congratulations, Miguel. We will be following up with you guys offline after today's webinar via email to get your Amazon gift cards to you. So please check your email. Take a look for that message. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We are going to be sending out an email in about an hour that contains a link to access the webinar on demand. So you can always check it out. You can also find it on the devops.com website. It will be living there as well. So just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Ted, Katie, thank you so much for your time today. What a great presentation.
Thank you so much, Charlene.
Yeah. So such a good information. I know, judging from the number of questions we got, you know, the audience got a lot out of it too. So also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.
See y'all.
Bye.